Let us now look at the first model from this topic of coordinate geometry, where we shall see how to calculate the distance between two given points. Let us look at the given statements here. We have four statements. The first one says the distance between 2 points A, which is described by x1, y1, and B described by x2, y2 in the xy plane. What is an xy plane? A Cartesian plane. Is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So we simply need to take the square of the differences of abscissa plus the square of the differences of ordinates under root to get the distance between the 2 points. The second point here says that the distance of a point A, where the coordinates are x, y, from the origin in the xy plane can be simply taken as root over x squared plus y squared. Now, a very simple point. Since we are calculating the distance from the origin, in the origin the coordinates are 0, 0. So what happens? The second point in our first statement becomes 0, 0, right? So x2 is 0 and y2 also is 0. So what do we get? x1 squared plus y1 squared under root. That is nothing but x squared plus y squared under root. So when we have to measure the distance from the origin, simply take root over x squared plus y squared, where x and y are the coordinates of the point A. The next point says that the distance between the points A, x1, y, and B, x2, y, is equal to modulus of x2 minus x1. Now what do you observe here? We have got 2 points A and B. The point A is having the coordinates x1 and y, and the point B has the coordinates x2 and y. What do we see? The second coordinate, which is known as the ordinate, in both the points is same. That is, the vertical distance of both the points is same, or the distance from x-axis of both the points is same. In that case, y2 minus y1 whole squared becomes 0. y2 minus y1 is 0. 0 squared 0. So what are we left with? Root over x2 minus x1 squared. Again, squared and under root gets cancelled. Simply we are left with x2 minus x1. So that is what we take here, x2 minus x1, and modulus sign, because we may get a negative value, but the distance should be a positive value there, right? So we simply neglect the sign and only consider the magnitude. So the distance between 2 points which have got the same vertical distance or same distance from x-axis can be taken as the difference of their abscissa, right, or x2 minus x1. And likewise, the distance between 2 points which are x, y1 and x, y2 can be taken as modulus of y2 minus y1. The same argument holds true for statement number 4 as well, right? Since the horizontal distance are same, right? X and x is the horizontal distance. Now the horizontal distance of both the points is same, which means the distance from y-axis is same for both the points. So we can simply take the distance between the 2 points as modulus of y2 minus y1. So the basis of calculating the distance between any 2 points is root over x2 minus x1 squared plus y2 minus y1 squared. Let us now take the first example from model 1, which is about calculating the distance between two given points. The question here is, if the distance between 2 points 0, minus 5 and x, 0 is 13 units, then x is equal to what? So as you see here, we have got 2 points. First one is 0, minus 5, and the second one is x, 0. X is the variable there, unknown value. The distance between these 2 points is given as 13, and we need to find out the value of x. Now we very well know that the distance between 2 points can be calculated as root over x2 minus x1 whole squared plus y2 minus y1 whole squared, right? This will give us the distance between the 2 points. Let us just substitute the given values. So what is x1? 0, y1 minus 5, x2 is x, and y2 is 0. The distance is given as 13 units. So let us substitute the values. x2 minus x1, that is x minus 0. X minus 0 squared plus y2 minus y1. What is y2? 0 minus y1. y1 is minus 5. So 0 minus of minus 5 whole squared equals to the distance is 13. So what do we get? This implies root over x squared plus 5 squared, 25, equals to 13. Now by squaring on both the sides, we get x squared plus 25 equals to 169, which implies x squared will be 169 minus 25, that is 144. Now if x squared is 144, what will be the value of x? It will be plus or minus 12. Remember, do not commit a mistake here by saying that x is equal to 12. X squared is 144, so x can take plus 12 or minus 12. So we can say that the answer for this question, that is the value of x, will be equal to plus or minus 12. So a very simple application of the distance between 2 points. And this is one of the earlier SSC CGL exam questions. Let us now look at the second example from Model 1, which also happens to be an earlier SSC CGL exam question. It says, what is the distance between the points 0, 0, that is the origin, and the intersecting point of the graphs of x equals to 3 and y equals to 4. Now it may sound a little complicated, but then when you actually solve it, you will find that this is a very simple question, right? We have to find out the distance between 2 points, right? We know that it can be taken as root over x2 minus x1 whole square plus y2 minus y1 whole square. Now one of the points is origin, and we also understand that when one of the points is origin, or we are calculating the distance of a point from the origin, it is simply root over x square plus y square. But what is the other point? The other point is the intersecting point of the graphs of x equal to 3 and y equal to 4. So we'll actually have to look at the graphs of these two equations, x equal to 3 and y equal to 4. Well, that's not really difficult to understand. Let us take the coordinate system, right? This is the x-axis, and here we have the y-axis with the origin at this place, right? The intersection here is the origin. Now it says x is equal to 3. What do you mean by x equals to 3? We have to draw the graph x equal to 3. Now x is equal to 3. We know that this is like different points on x-axis, 1, 2, 3 and so on. So x equal to 3 will be at this point, right? This is like 3, 0, x equals to 3, y equals to 0. And y equals to 4. What happens? This is 1, 2, 3 and 4. So y equal to 4 implies it falls on y-axis, where x is equal to 0 but y is equal to 4. Now we need to find out the intersecting point of the graphs. Understand, we have not drawn the graphs yet. We have only looked at the points where it meets on x and y axis respectively, right? X equals to 3 meets at 3, 0 on x axis, and y equals to 4 meets at 0, 4 on y axis. Now what do you mean by a graph? It will simply be a straight line, right? X equal to 3. So if you draw a line like this is the line which denotes x equal to 3, right? The distance of this line from y-axis, the horizontal distance, is 3 units. Likewise, the distance of this line y equals to 4 from x-axis is how much? 4 units. So this is 4 and this distance here is 3. So this line indicates x equal to 3. Alright, and this horizontal line here indicates y equals to 4. We'll probably understand this much better when we look at the equations of straight lines. However, considering two simple equations, x equal to 3 and y equals to 4. What is the point of intersection? This is the point of intersection. Let's say P, the point of intersection P. And what will be the order pair for that point P? It will simply be 3, 4. Yes or no? This point will be 3, 4. 3 units from y-axis, the horizontal distance, and 4 units from x-axis, the vertical distance. 3, 4, which is the basis of the Cartesian coordinate system. Now we need to find out the distance between origin and this point P, which is this distance. Alright, we have to calculate this distance d here. We know that the distance of any point from the origin is simply root over x square plus y square, right? The point here is 3, 4. So what will be the distance from origin? It will be equal to root over 3 squared plus 4 squared, which is 5, right? 9 plus 16 is 25, under root 25 is 5. So 5 units will be the distance of the intersecting points of x equal to 3 and y equal to 4 from the origin O. So this is how we can draw the graphs for the equations x equal to 3 and y equals to 4, which are really simple to find out the point of intersection and then calculate its distance from the origin O.